In today's lesson, we are going to be talking about trig component form. So first, let's talk about what a direction angle is. So direction angles are given with 0 degrees on the positive x-axis, rotating counterclockwise, or you may see it used with, or see it given with directional words. So for example, 60 degrees east of south. All right, so here's an example, 60 degrees east of south. How do you draw that when you're looking at your north, south, west, east? So think of it this way. Think of it starting at south, and you want to rotate 60 degrees towards east. So make that angle there, 60 degrees. So that's where we are. Now, if you're trying to find, starting on the positive x-axis, just how much we've rotated, that is going to be 330 degrees, right? 270 degrees plus the 60 degrees gives you 330 degrees. So the direction angle would be 330 degrees. Now the reference angle, just like we used to use reference angles last chapter, or last couple of units with trig, that's going to be 30 degrees. Okay. Now, when you are performing calculations for what we're doing today, you are going to be using reference angles. Okay, so all that work that we did in trigonometry still comes into play here. All right, take a look at example 1. Vector A has a magnitude of 50 meters in a direction of 30 degrees north of west. Find its component form. Let's draw this out. So 30 degrees north of west means start at west and rotate towards north by 30 degrees. So that here is 30 degrees. Okay, just for practice, that means that starting from the positive x-axis, rotating to this point here, that would be 150 degrees. Now, what we're trying to do is we're trying to find this vector that we've drawn in, the one that's labeled with a magnitude of 50 meters, and we're trying to write down its component form. That means we want the x component and the y component, right? So the parts that are in pink here. Now, how do we figure out what the x and y components are? Well, it looks like we have a right triangle here, so let's apply our knowledge of right triangle trigonometry. So to figure out what x is, well, we have 30 degrees, we have x, which is the adjacent side, 50, which is the hypotenuse. So it looks like we can use cosine of 30 equals x over 50. Get x by itself, so we have x is equal to 50 times cosine of 30. So x is equal to 43.3. We can do the same thing for y, but this time using sine. So sine of 30 degrees is equal to y over 50. And then get y by itself, so we should get y equals 25. And actually, you should know that y equals 25 without necessarily needing to do the calculation there, because you know sine of 30 is equal to 1/2, right? So half of 50 is 25. Okay, now the only other thing is, if you're looking at what we have here, the components, x, that magnitude is 43.3, and y, that magnitude is 25. But we need to indicate a direction, right? So the x component moves to the left, right? If you're looking at the direction of the arrow, which is the vector, you can clearly see that that is negative 43.3. And then y component goes up by 25, so it's positive 25. So negative 43.3, comma, 25. All right. Next, finding component form. So let's kind of generalize this. So in general, the component form of v, vector v, with a magnitude of whatever that is, so we've written it out here in symbols, and reference angle theta is given by this. So the first component is always the magnitude of v times cosine of theta, and then the y component is always going to be the magnitude of v times sine of theta. Then, after you have that, you need to apply negative signs, like just what we did at the end of our last example. Apply negative signs where necessary to account for which quadrant you're in. Okay. The reason why you need to do this is because you're using a reference angle. Anytime you use a reference angle, you're referencing it, which means it could be off by a negative sign, right? So anytime you're using a reference angle, you have to take into account, okay, should this be positive? Should this be negative? Which quadrant is this in? Does this make sense? All right, next example. Find the component form of vector w with the magnitude of vector w equals 20 and a direction angle of 215 degrees. Okay, let's draw this out. So 215 degrees takes us into the third quadrant here. That's a reference angle of, well, 215 minus 180 gives us 35. The magnitude here is 20. So now we have the reference angle, we have the magnitude. Now we can go ahead and plug into that formula. So vector w has components x, 20, cosine 35, and y, which is 20, sine of 35. And then just take into account, well, which quadrant am I in? I'm in the third quadrant, which must mean that both my x and my y components will be negative. So that'll be negative 16.4, negative 11.5. Okay, great. Now what if you were trying to find the direction angle? So right now we've been able to start from the direction angle and come up with the component form. But what if instead you're trying to find out what the direction angle is? So a couple of things to note before we get into that. When you are finding the direction angle, your calculations always yield reference angles. Okay, that's important to note because if you're finding the direction angle, you do a calculation, you're going to get a reference angle, you're going to have to do an extra step in order to get the direction angle. All right, next, always use absolute value of components. And then lastly, always use degrees. You'll notice that everything we've done at this point has been in degrees, and when we are working with vectors in general, we will be using degrees. All right, take a look at example 3. Find the direction angle of vector v, which has components negative 3, negative 4. All right, let's draw this out. So negative 3, so going 3 to the left, and then negative 4 for our y component, so going down by 4. So here is our vector v. We want to know what the direction angle is. So we're going to start by figuring out what this reference angle is, and then once we find that reference angle, we'll be able to determine the direction angle. Okay, so we'll call that theta. Well, just like before, we are working with a right triangle, so tangent theta is equal to 4 over 3. And to find theta, we just find tan inverse. Again, make sure your calculator is in degree mode. So tan inverse of 4 over 3 comes out to be about 53.1 degrees. But remember, we're trying to find the direction angle. So here we did find theta is 53.1, but the direction angle is starting from the positive x-axis. So this measurement is what we're trying to find. So we just have to add 180 to 53.1, and that comes out to be 233.1 degrees. So that is the direction angle. So let's generalize that. So in general, the reference angle for a vector v in component form, we'll call the component form x and y, is tan inverse of the absolute value of y over the absolute value of x. After you find that reference angle, right, remember this gives you the reference angle, then you have to find the direction angle by adjusting for the quadrant that it is in. So you'll probably need to draw it out, determine which quadrant it's in, and from there you'll be able to use the direction angle, either adding or subtracting off that reference angle in order to determine the direction angle.